Hey guys, and welcome to the Ohm's Law lesson here. So we're going to talk through what Ohm's Law is and how it works. So when it comes to how electrons flow, we've discovered, well, several mathematical relationships. One of them, one of the main equations, if you will, is called Ohm's Law, which is a description of the relationship that exists mathematically between current, voltage, and resistance. And so here it is. This is Ohm's Law. This is the equation we're using today. Voltage, V equals IR. So in this equation, V is your potential difference, measured in volts. V is for volts. I is your current, measured in amps. So if you're looking at your light bulb or this, whatever, it is in amps. How much current you have, how fast electrons are moving. R is your resistance, measured in ohms. That's why they call it Ohm's Law. So if I know two of these things, I should be able to find the third one. So this math formula can help us a ton. If you know any two, if you know the voltage and the current, I can tell you how much resistance is on that circuit. If you know the resistance and how fast the electrons are moving, you know the current, I can tell you how powerful the battery is that you've hooked up. I can tell you your voltage. So we can calculate what the missing one should be to get a better understanding of how a circuit is working. So here's our example. Just do a little easy one. What is the current? So V, I, R. What is the current in a 120 volt circuit if the resistance is 20 ohms? 2 ohms. And so what you're seeing here is step one for most math equations, the easiest way to do it, write down all the stuff the question is telling you, even if you don't know something, like what is the current? Notice that I put a little question mark by the I. Step two, plug this into our formula. So my V is 120 volts. My I don't know, so I'll just leave it as an I. And my resistance is 2. And if two things are touching each other in a math equation, it means they are multiplied. So 120 is I times 2. So in order to solve this math equation, I need to get I all by itself. I need nothing touching the I. And right now, I have a times 2 touching the I. So how do I get rid of a times 2? Well, what's the opposite of a times? The opposite of a times is a divide. So I divide by 2. That'll cancel itself out. 2 divided by 2 is 1, and I times 1 is anything times 1. It's just itself. But if I divide by 2 on one side, the rules of math say I have to divide by 2 on the other side. So alright, times 2 divided by 2, those kind of cancel each other out, and I'm left with just I, which is what I wanted. What's 120 divided by 2? Oh, it's 60. So I is 60. Oh, what are the units for I again? What is I measured in? I is your current measured in amps. So I equals 60 amps. I have 60 amps of current in this circuit. Now, if you are good at algebra, I encourage you to solve it exactly this way. It's the easiest way to solve these things. Plug them in, divide if you have to, figure out what you're doing. Do it the way you normally would in math. But if math is not your thing, if math is really tricky, I'm going to show you a magic triangle for algebra. So here's our triangle. Looks like this, kind of like a pyramid. It's more of a pyramid than a triangle. V equals I times R. So how this magic triangle works, and if you're not good at algebra, I would write this down in your notes. How this magic triangle works is it tells you how to do your math. So let's take the question we just did. What is the current in a 120 volt circuit? So I need to find current. I need I. So what I do is I cover up the I. Pretend it doesn't exist for a second, and there's my formula. V on top of R, V over R. I have to take my volts and divide it by my resistance. And this works for every single one of our things. If I needed to find voltage, it's I beside R. It's I times R. V equals I times R. If I needed to find resistance, it's V divided by I, because the V is on top, V over I. So this little magic triangle can be used to tell you your formula if you're not good at math. It's a little shortcut for finding the formula if you don't want to do it the algebra way. But if you're good at math, I'd recommend doing it the algebra way. It's really good practice. It gives you a better understanding of the numbers, and it'll help you more, to be honest, if you're going to end up taking, pre-cal, chemistry, physics, any of the higher level sciences or maths. It'll be helpful to get this practice. So please try to do it the algebra way, but if you really can't, the magic triangle can help you. So, what voltage is required to move 6 amps, current is 6, through 10 ohms of resistance? So whenever you see ohms, it goes with resistance. Whenever you see amps, it goes with current. So my formula, Ohm's law, V equals IR. I don't know V. I know I is 6. I know R is 10. Well, this is an easy one. I don't have to rearrange anything. 6 times 10. I would need 60 volts. Fantastic. What is the resistance of a circuit with 3 1.5 volt batteries? Oh, okay, so let's start with it. What is the resistance? Well, that's what I need to find out. 3 1.5 volt batteries. 3 1.5 volt batteries. So I'm going to put them in series, which means they add together. 3 times 1.5. 1.5 plus 1.5 plus 1.5. So I have 4.5 volts in total, and it's running at a current of 5 amps. So I just read the question, wrote down what I knew. I'm going to solve this twice. Once algebraically and once with the magic triangle. So voltage is 4.5. I is 5. Resistance, I don't know yet. I know these are times by each other because they're touching, so I'd have to divide both sides by 5 to get my answer. So the 5 and the 5 are going to cancel out, and you're going to have to grab your handy-dandy calculator and do 4.5 divided by 5. 0.9 equals R, because 5 and 5 cancel. What are my units for resistance again? Oh yeah, ohms. It's almost 1 ohm of resistance. Now, if I want to do it magic triangle way, I would still do this step. I would still set it up. But then I would draw my triangle. It's always the same triangle. V, I, R. What I'm trying to find is resistance, because that's the one with the question mark. So resistance is V divided by I. V is 4.5. Right, because I found that over there. And I is 5 amps. So I just divide these two. I just plug it into the calculator. A fraction is the same as a divide. 4.5 divided by 5. And I get the same answer. 0.9 ohms. Alright, cool. So why? Why do we care about this? How's this going to help us with our electricity stuff? Well, if you look carefully at the base of a bulb, you can barely see it there. This picture's really blurry. But if you look carefully at the base of a real light bulb, the little science ones, a lot of times they have a preferred voltage and a preferred current to get the best light out of it. Now, you might not find these on your lights at home because your sockets are all like programmed to be a certain voltage. They always run 120 volts, so they don't even mark that on the bulbs. But a lot of little bulbs will have, this is the voltage, this is the current that I need to get the best light out of this bulb. So if I know current, and I know volts, I could actually calculate how much resistance is in the light bulb wire. So this bulb, let's say, is marked 2.4 volts and 0.3 amps. How much resistance do we have? All right. Oh, current. V equals IR. I know my voltage is 2.4. I know my current is 0.3. Divide both sides by 0.3. So once again, your 0.3s will cancel out. You grab your calculator, you do 2.4 divided by 0.3. And you know that that bulb has 8 ohms of resistance. Awesome. Fancy. Okay, again, Mr. Burns, why do we care? Well, we can use Ohm's law in our work with circuits. For example, if we want to use more than one battery, we need to be really careful not to overload a bulb and burn it out. If you put too many batteries in a series, the bulb will just burn. It'll burst. Too much energy for it. But how do we know when a bulb is overloaded? We might have different amounts of voltage, but as long as we don't go over a battery's preferred current number, a bulb's preferred current number, which again was written on the bulb, you shouldn't burn it out. So if the max current a bulb can handle says it works best at 0.5 amps, and we want to use a 9-volt battery, how much resistance do we need in total on that circuit? So the more resistance I put in, the slower the current would move. So I gotta find my resistance. Voltage is 9. Current is 0.5. I don't know resistance. Divide both sides by 0.5. Resistance equals, I need 18 ohms of resistance in total. If I don't have 18 ohms of resistance on this bulb, I am going to have a problem. Alright, so I need 18 ohms of resistance. Cool. Let's put that all together. You have a bulb marked 3 volts, 0.5 amps. That's what the bulb likes. But you got a 9-volt battery. If you want to power this up, how much more resistance do you have to add? Don't forget, the bulb has some resistance already to make sure you don't blow up your bulb. So first, what is the resistance of the bulb? Alright, well the bulb was 3 volts, and it likes 0.5 amps. So if I divide both sides by 0.5, my bulb's resistance is 6 ohms. So pause it here if you want, work it through, make sure that that makes sense to you. What's the total resistance needed for the circuit? Same formula. I know I've got a 9-volt battery. I'll put it over here. 9-volt battery. I know that my bulb only likes 0.5 amps. So how much resistance do I need? Divide both sides by 0.5. I need 18 ohms in total. So I don't have enough resistance. I have 6 in my bulb, but I need 18. Otherwise my bulb will blow up. So if I have 8, I need to get to 18 ohms, and I've already got 6 in my bulb. I need to add 12 more ohms to slow things down. I need to find a way to add 12 ohms to this circuit in order to make sure I don't burn out my bulb. Okay, we need 12 ohms. Great. Excellent. We know how much we need to add. How do we do it? How do I add resistance to a circuit? Well, you can use something fancy called a resistor. They look something like this. So what do those colored straight means? How do I get 12 ohms? How do I make this thing work? How do I build this, Mr. Burns? Well, you're going to have to wait. We're going to have another video that talks about how do I read resistors, how do I use resistors, and I'm sure that'll be very interesting to everyone. Those colorful bands are a lot of fun. So thanks for watching, guys, and I will see you next time.